last meeting, we answered up to this number 3, as you can see. So for today, we will continue with our problem solving. So now let's answer number 4. Number 4, the body on the 30-degree incline in the figure is acted upon by a force P inclined at 20 degrees with the horizontal. If P is resolved into components parallel and perpendicular to the incline, and the value of the parallel component is 1,800. Sorry. Yeah, this is number 3. Moving on to number 4. Number 4. In the figure, the x component of the force P is 140 pounds to the left. Determine P and its y component. So pretty straightforward. So first, we have this figure, okay? And then we're given the x component of force P, which is 140 to the left. And now we just want to know the value of P and then its y component. So let's write out our given first. Once again, we have x component, so let's call that Px. £140 to the left. And remember our sign convention? Downwards to the left is negative, so that is negative 140 pounds. Right, now let's solve. So you have this P. We already know how to solve for x and y components, right? If we're given slope. So when we're given slope, first step is to find out the hypotenuse r. To solve for r, recall Pythagorean theorem, square root of 7 squared plus 4 squared, and that is just square root of 65. So this is square root of 65. Now let's solve. Since we're given Px, let's start with Px. Px equals, so looking at our drawing, P is to the left, therefore this is negative. And then your force P multiplied by, since we're looking for force on the x-axis or the x component, or rather, we're creating an equation for the x component, recall our technique whenever we're given a slope, Px, therefore I need to get the side that is parallel to x, and that is 7, right? Parallel to x, this is your x, or the side that is horizontal. So times 7, and then just divide by the hypotenuse, square root of 65. And then write out our values. Px is negative 140, negative 140 equals negative P times 7 over square root of 65. Please solve. What's P? Correct, it's 161.25. Correct, Marilyn and Rick Pollen. So Pere and Peliosis. Len and Colin. 161.25, and then write out its unit, pounds. So this is pounds. Now that we have P, next thing to solve for is Py. So create an equation for Py. Py equals, look at the drawing, it's upward, therefore positive. Then your force P times, we're looking for Py, so we need the side that is parallel to y, or the side that is vertical, and that's 4. So times 4 over hypotenuse, square root of 65. We know P is 161.25. Then as I've said in the previous meeting, whenever we have an answer like that, typically we want to store that value. Using the stored value of P, sub that in here, and then from that we can solve for Py, Please solve. What's the answer? Correct. It's just 80. If you use the stored value of this, you should just get flat 80. So correct, Tabug and or Rafael and Rafaela and Eman. Oh, marami pa lang. And Matthew and Matthew. Okay, so Matthew and Eman gets the point. Danilo and Centones. Centones. It's 80. So 80. So again, unit. That's how you get force T if you're just given one component. Any questions for number 4? Please answer in the chat. Okay, great. Let's move on to number 5. Number 5, compute the value of the resultant of the concurrent forces shown in the figure. So we're done now just solving for the components. Now we have to solve for the resultant of a concurrent force system. So to do that, recall, we already know how to get the x and y components, right? So to get the resultant, you just take the summation of all the x and all the y components and then use Pythagorean theorem to solve for r, which is the resultant. So let's do that. We have this figure. Okay, check the given. So we're given forces, but we're also given the slope. So whenever you see a slope, solve for r. So first of all, solve for r. So again, r is just 1 squared plus 2 squared. Take the square root of that, you should get square root of 5. Okay. And from that, we can now start solving for rx and ry. Let's start with rx. Okay, if you recall from our lecture, rx once again is just summation of forces x. You already know how to do or how to get forces x. Now it's up to you where you want to start. I want to start with the 100-pound force, so let's do that. So 100 pounds, check first if it's positive or negative. It's to the right, therefore positive. And then we're given slope. So the equation of that is your force, 100, multiplied by, we're looking for x component, so this is the side that is horizontal, so times 2 over resultant square root of 5. Not resultant, hypotenuse square root of 5. Let me just write that. It's easier to see. Square root of 5. We're not done. Let's continue on to the other forces. Let's try the 300-pound force. It's to the left, therefore negative. And then we're given angle. Recall the equation for the x component of a force given an angle. That is just F cosine theta. So negative F, which is 300 cosine theta, 60. Next, this to the left, so minus 200 cosine 45. And then lastly, your 400-pound force to the right, so positive 400 cosine 30. Please compute what's the final answer here. Correct, Rafael and John, or Sosa and Tabu. JL. 144. It's 144.43. Store that in your calculator. Store. Okay. Now let's do the same thing for Ry. Once again, after storing this in your calculator for easy retrieval. So Ry is just is just summation of forces y. Once again, let's start with the 100-pound force. Upwards, therefore positive 100 times. We're looking for the y component, so we're looking for the vertical side. So that's 1. One over square root of 5 here. No, it's 2 over square root of 5 since x component. It's 2 because, again, we're looking at the horizontal side. Okay? Yung 1 over square root of 5, you use that for the vertical component, for your Fy. So this is where you put your 1 over square root of 5. So times 1 over square root of 5. Once again, because we're looking at the vertical side, we're looking for the vertical component. Okay? Then next, move on to the 300-pound force. It's positive since it's upward. So positive 300, and recall the equation for y component when given an angle, that's just f sine theta. So f 300 sine, and our theta is 60. Next, 200 is downward, therefore negative 200 sine 45, and then lastly, this is also downward, so negative 400 sine 30. Please compute what's the answer here. Negative 36.89. Very good. Nicolas Tabug, you already have 2 points, so I won't give it to you. Remember, when you have 2 points, allow the others to. Sorry. Oh yeah, this is your second point. Never mind. So Nicolas and Tabug. Buena. Negative 36.89. Now, when we're solving for the values of our forces, just directly, the negative sign denotes its direction. Okay? So previously, our positive and negative denotes assumption, correct or incorrect assumption, right? When we have a negative answer, our assumption for direction is incorrect. However, that's only for comparing two equations. Here, we're just solving for a value. Therefore, the answer that we get is its direction. So this is negative, therefore this direction is to the left, or rather downward, since this is Ry. Okay? It's the difference between getting a negative answer in comparing two equations to getting a negative answer in solving for a value. Right? So now we have Rx and Ry. We can solve for resultant R by using the Pythagorean theorem, square root of Rx squared plus Ry squared. Remember, store this as well so that the answer is more accurate. Or also so that we have uniform answers. So since Rx is 144.43, again using the stored value, same with Ry, negative 36.89, once again use the stored value. Please solve for R. What's the answer? So it's 149.07. Correct. Rain and Matthew. Carol, Carol, 2, 1. So 149.07 unit. Okay, now we're not done. This is just the magnitude of your resultant. Now we need to get the direction. To get the direction, we'll use our equation. Theta equals arctangent Ry over Rx. And it's not mentioned there or written there, but this is just the absolute value. So that you can just ignore the negative sign here in your answers when solving for theta. Okay, please solve for this. What's the answer here? What's theta? Correct, it's 14.33. Correct, Lauren and Naomi. Chua, so. Chua, J. So 14.33 degrees, and someone mentioned it. It's southeast. Correct, Marilyn. I'll give you a point as well since you mentioned the direction. Southeast. Why? Your direction will depend on the sign of your Rx and Ry. Rx, final answer is positive, therefore it's to the right or east. Ry is negative, therefore it's downward or west. South, sorry. So southeast or downwards to the right. Since we're not talking about bearings, let's use down or downwards to the right. Okay. Again, that direction depends on the sign of your Rx and Ry. Okay. So that's number 5. Any questions for number 5? Please answer in the chat. Okay, good. Next, number 6. Forces F, P, and T are concurrent and acting in the direction as shown. Find the value of F and alpha if T equals 450 newtons, P equals 250 newtons, and beta is 30 degrees. And the resultant is 0. So basically, we're looking for F and alpha. So first step, let's write out our given. P is 450, P is 250, beta is 30, resultant is 0. So, what? So P is 250. T is 450. And then beta is 30. So this is 30 degrees, and then resultant is 0. So when we say resultant is 0, that means Rx and Ry are also 0. So from that, we can create our equation to solve for F and alpha. So you can start at either Rx or Ry, up to you. Let's try starting at Rx. Once again, Rx equals 0 since R equals 0. And let's create our equation. Rx is just summation of forces x. So you can write that Rx summation of forces x, and then Rx is 0 equals. Let's start with F. F is to the right, therefore positive, and then our angle is alpha. This is the x component, so the equation is F cosine alpha. Next, P. P is 250 to the right, therefore positive, so plus 250 once again cosine, and then we're given angle 30. And then we have T to the left, directly horizontal, so that's just negative 250, 450. We can't create an equation or we can't solve anything from here since we have two unknowns. So instead, you can just write this as equation number 1. Now we move on to the next component, which is Ry. So Ry, summation of forces y, and then Ry is 0. And then let's create our equation. Let's start with F again. It's upward, therefore positive. Equation for y component is F sine alpha. So sine alpha. Next, P is downward, so negative P, which is 250, given your angle, so sine 30. This doesn't have a vertical component, so that's all of your equations. Once again, there's nothing to solve for here, so we can just call that equation number 2. Now look here, we have two equations. We also have two unknowns. Recall from your math subjects, when you have the same number of equations and unknowns, your variables are solvable, or your unknowns are solvable. Now you can either use your calculator or manually solve for this. Let's try manually solving for this by writing one variable in terms of the other, and then subbing it to the other equation. Okay, so let's take this equation number 2. Let's rewrite that. Okay, so this becomes, let's transpose 250 sine 30. So we have f sine alpha equals 250 sine 30, right? And then divide both sides by sine alpha, you get f equals 250 sine 30 over sine alpha. And then we sub this into equation number 1. Okay, subbing it in 1, we get 0 equals, again, subbing f, 250 sine 30 over sine alpha. Okay, times cosine alpha plus 250 cosine 30 minus 450. Simplify all of this. We get, I'm gonna move 0 to the right so that it looks neater. So sine 30, or rather cosine alpha over sine alpha, that's cotangent, right? Cosine over sine. So this becomes 250 sine 30 cotangent alpha. Okay? And plus 250 cosine 30 minus 450 equals 0. And from this, I can solve for alpha. Can anybody solve what's alpha? Okay, let me write it out. Very good, Zaira. Yep. No. Okay. So only Zaira got it. So correct. Zaira, let me give you the point. Martins, please. So it's 28.16. To solve this in your calculator, first of all, let's store that. To solve this in your calculator, you're gonna write tangent. So shift tangent, tangent -1. Since this is cotangent, it's 1 over 450 minus 250 cosine 30 over 250 sine 30. Okay, that's how you compute it in your calculator. Some of you did 1 over tangent 450, etc. Okay, that's incorrect. Do it this way. Okay, practice your calculator techniques until you can get this. Okay, now we have alpha. What are we gonna do here? Now, we sub this into equation 2. Or you can sub it here. Or you can sub it here. You'll get the same answer. So sub in 2. And then upon subbing in 2, you can solve for f. Please solve. What's f? So again, sub this here or here to solve for f. What's the answer? Correct. Rafael, Lauren, and Rain. Kabog Chua Pochero. Kabog tu kami. Chua and Poche. Sumon. Chua. Right. It's 264.85 to be exact if you use the stored value. Okay. 264.85. Unit. What's our unit? It's why is this? It's Newton, I believe. Newton. And there, that's our answer. And that is our number. Okay. 6. Okay. Any questions for number 6? Please answer in the chat. Okay, no questions. Let's move on to number 7. Number 7, the block shown in the figure is acted upon by its weight W, which is 200 pounds, a horizontal force Q, 600 pounds, and the pressure P exerted by the inclined plane. The resultant R of these forces is up and parallel to the inclined, thereby sliding the block up it. Determine P and R. Okay. So once again, let's start with our given. Okay. This is number 7. So we're given R. They said that R is upwards to the right along the incline. So this is your R. To make things clearer, let's try drawing a free body diagram of this. Okay. Just to make things clearer. So drawing the free body diagram. Okay, this is your point. We have a downward force W. We have Q to the right. And then we have P. And then this is your P. Q 600. And then we know that R is somewhere here. Let's following the slope of your incline. And our goal is to solve for these two. So my first problem is I need to know the angle of P from the horizontal, since what we're given is the angle of P from the perpendicular line to our incline. So that's the first thing to figure out. Okay, so let's try and solve. Once again, using your previous math classes, recall your theorems on angles, we have angle 30 over here. Now, if I draw another horizontal line here, recall, we have two parallel angles. If this is 30, therefore this is 30 as well, okay? They're parallel angles. Now, this line is perpendicular to the incline. This line is horizontal. So therefore, also this line, rather this angle is from the incline as well. So this total angle should be 90, right? Since this line is from, or rather this line is perpendicular to our incline. So this is 90, this is also 90. This is 30, this is 15, so we can solve for P. P is just 90 minus 30 minus 15, and that is 45. Correct? 90 minus 15 minus 30. So P equals 45 degrees. Okay? So that's how we got, no, not P, the angle of P from the horizontal line. This is 45 degrees. Okay, so that's easy enough. Let's now move on to actually solving. So let's transfer that into our free body diagram. So this is your 45. And now it's easier to see how to create our equations. Let's start with Rx. Since we're just going to use equations for Rx and Ry to solve for R and P. So Rx is just summation of forces X. But what is Rx? Okay. Rx is, okay, let's create an equation for it. This is R. Let's take its angle from the x-axis as well. Since it has the same incline or has the same slope as your incline, then it's also 30 degrees. Okay. Knowing that R is 30 degrees from the horizontal, we can solve for its components. Rx is just R cosine 30, right? In the same manner, Ry is just R sine 30. And now I can use that in our equation. So Rx is R cosine 30. Next, let's use summation of forces X. So let's start with P. P is to the left. Try to notice your arrowheads, okay? So this is to the left, so that's negative. And then equation given angle is F cosine theta. So this is negative P cosine 45. In the same way, W doesn't have a horizontal component, so ignoring that. And then we have Q to the right. That's just positive 600. We have two unknowns here. I can't solve for anything yet. So once again, just call that equation number 1. Next, let's do the same thing for Ry. So Ry is just summation of forces X. Forces Y. Ry is R sine 30. Let's begin. P, as you can see, is upward. Therefore, positive P sine 45 for the Y component. Next, W is downward. The weight is given 200. So minus 200. And then Q doesn't have a vertical component, so ignoring that. Once again, two unknowns. Can't solve for anything yet. This is equation number 2. Now look here, we have 2 equations, 2 unknowns. Once again, using simultaneous equations, I can solve for R and P. So you can solve for this manually, or I'm going to teach you how to solve for this using your calculator. Try to look for the equation function of your calculator. For those using Casio 991 ES plus, or just 991 ES, I think it's the same. You're gonna do alpha mode. Try to do this in your calculator. Okay, alpha mode. And then you're gonna choose 5 for equation. Okay, equation. And then you're gonna see things like ANX plus BNY equals CN, so on and so forth. You're gonna use or choose the equation that fits what we have. So ANX BNY equals CN. That just means 2 unknowns. So that is what we'll use. So choose your ANX plus BNY equals CN. Okay, and then you're gonna get a matrix looking like this. So the things that you will input in your matrix should pattern what you have here. Okay, so choose first what you want to be your first value. Let's say R. Okay, so looking here at equation number 1, so R, you're gonna write the coefficients of each variable. So this is R, this is, we're gonna write here cosine 30. And look at how our equation was written here in the options of your calculator. It should be ANX plus BNY equals CN. So I need to rewrite this in this form. So R cosine 30 plus P cosine 45 equals 600. Right. Since I need variable 1 plus variable 2 equals constant. So variable 1 is cosine 30, variable 2 is cosine 45, variable 3 is 600. You're going to do the same thing for the next equation. You have this. So variable 1, we have sine 30 as its coefficient. Variable 2, once again, you're going to transpose that here. You're going to get a negative p sine 45. So input negative sine 45 here. And this is negative 200, so negative 200. Click enter. The first variable that you'll get, or the first answer that you'll get, will be for R. The next one would be for P. So please do that and give me the answers. What is R? Okay, very good. It's 292.82. So correct, Rafael and Lawrence. Asagi and Bozo. Wala ka pa sa class list ko, right? Let me just add you. Right, it's 292.82. And then, yeah, yes, don't worry. I'll add you guys to class list if you get point. And then what's P? Correct. JM, and again, M1. So ilustrate and synchronous. To illustrate. Okay, 489.90 pounds. Don't forget the unit. So there. That's how to make your computations faster. Try to use your calculator techniques. And that's your R&P. Any questions for number 7? Please answer in the chat. Okay, great. For those that don't have your Casio 991 ES, you're using a different version, try to study or search what's your equivalent to getting equations. Okay, so that you don't have to solve for this manually. Or if you want to, you may. All right, no questions for number 7. Let's move on to the next slide. So the next slide is actually the next topic, which is moment of a force. Okay, so now we're done with components and resultant of a concurrent force system. Now let's talk about moment of a force before we move on to resultant of parallel and non-concurrent force system. Let's begin. So, the moment of a force about an axis or line is the measure of its ability to produce turning or twisting about the axis. So that's the general definition of what a moment is, ability to produce turning. In terms of equation, the magnitude of the moment of a force about an axis, which is perpendicular to a plane containing the line of action of the force, is defined as the product of the force and the perpendicular distance from the axis to the line of action of your force. Okay, for example, we have a force here. We want to take the moment about point O. So the equation there is force times perpendicular distance to point O. So F times T. So that's how our equation for moment came to be. Simply force times perpendicular distance. Now that perpendicular distance can also be called as moment arm or lever arm. So the moment or lever arm is the perpendicular distance between the line of action of the force and the center of moments. Now the center of moments may be the actual point about which the force causes rotation. It may also be a reference point or axis about which the force may be considered as causing rotation. It does not matter as long as the specific point is always taken as the reference point. The latter case is much more common situation in structural design problems. So that means your moment of center is up to you. You can choose it anywhere, okay, as long as it helps you solve for the problem, solve for the variables needed. For example, here, okay, our moment arm or lever arm is your D. Moment center here is O. So it's the point where you take your rotation. Similar to your forces, we also have sign convention for moments. So clockwise is positive, counterclockwise is negative for this class. Now, if you try to look at other books or if you experience MEC30 from another professor, there could be a case where their sign convention is negative, or rather, it's the opposite of what I just said. So for some books, clockwise is negative, counterclockwise is positive. Okay, that's because sign convention again is arbitrary, meaning there's no real rule on how to determine if something is positive or negative for moment. However, for the purposes of our discussion and for uniformity, clockwise is positive, counterclockwise is negative. Okay, so that's just our sign convention. Next, we have what we call your Varanon's theorem. The moment of a force is equivalent to the sum of the moments of its components. We use Varanon's theorem if it's hard to compute for the perpendicular distance. So instead, we're going to divide your force into its components and take the perpendicular distance of each component. So the equation here is M is summation of force times distance. And then using components, M is equal to summation of your forces x times their perpendicular distance y. That's distance y, not differential y, okay? Distance y. And then plus summation of forces y times distance x. Again, that's not differential x, that's distance x. To illustrate, let's have this figure. According to our discussion, moment is just force times distance. Okay, and then you're gonna choose a moment center that will help you solve your problem. Here, this is just an example. Let's say I want to take the moment about A. Okay, point A. So that's your MA equals summation of FB. Okay, let's start with force 1. Your force 1 is here. Okay, you can just extend that line of action and take this perpendicular distance to A. Perpendicular distance is 1, so that's easy to solve for. Now, you also need to know what's its direction. Is it clockwise or counterclockwise? Now, for me, the way I figure out if it's clockwise or counterclockwise is I physically try to rotate it about your point. So this is your F1 following that direction. As you can see, that's clockwise, so that should be positive. Remember to take the shortest path, and that's this, because if you do it this way, right, you're changing direction. That's more awkward to draw instead of this. So that's positive since clockwise. So positive F1 times perpendicular distance 1. Now what about F2? If I extend the line of action of F2, I get something like this, right? And perpendicular distance is here. Now this perpendicular distance is a bit of a hassle to figure out. So instead of using that, I'm going to divide my force F2 into components F2x and F2y. Okay, let's start with F2x. Rotate F2x about A. Once again, that's clockwise. So positive. So positive F2x. And then now to get the perpendicular distance, okay, extend the line of action, take this perpendicular distance. And as you can see, that's given. That's equal to 1. So F2x times 1. And then lastly, F2y. Once again, rotate F2y about A. You have this. That's counterclockwise, right? So minus 2y. Extend this line of action. This is your perpendicular distance, and that is 2 times 2. Okay? And that's how you take or you create equations. Okay? So that's it for moment, concept of moment. Any questions for the concepts of moment, please answer in the chat before we move on to our examples. Again, please answer any questions, yes or none. Okay, since you don't have any questions, let's move again to examples. Let's start with number 1. In the figure, a force F passing through C causes a clockwise moment of 120 foot-pound about A and a clockwise moment of 70 foot-pound about B. Determine the force and its x-intercept. Let's do that. So that's equation of problem number 1. Okay. So I removed your fx, fy from the figure. Okay. Fx and fy is already given. I'm going to show you how that came to be. So first of all, let's look at the given. you have a force passing through C, and this is your point C. And then it creates clockwise moment of 120 about A, and clockwise moment of 70 about B. They're both clockwise, therefore they're both positive. Okay, so now let's write out that given. Moment A, 120, moment about B, 70. I'll write it here. Moment about A means A is taken as the moment center, and then the answer for that would be 120 unit pound foot. And then moment about B was 70 pound. Once again, clockwise, so positive. Now we need to know, determine the force and its x-intercept. So you're looking for F. And then x-intercept, meaning this distance, or also known as Ix. So let's start analyzing. First, I need to know the direction of my force. All we know is that it follows this path, or this is the line of action. Now there's only two choices there. It's either upwards, or downwards. Okay? No matter the direction though, it should follow that its moment about A is positive or clockwise, and its moment about B should also be clockwise. Now let's consider the direction as downward. What's gonna happen? Okay? If you try to rotate this force about B, you get counterclockwise moment, right? Same with A, rotating it about A. Once again, that's a counterclockwise moment. So it's not downward. Now let's check if it's upward. If it's upward, rotating it about A, you get clockwise. Same thing. Rotate this about B, that's again clockwise. Okay? Now you may ask, why am I not doing it like this? Because once again, this is upward and you're going to go downward. Goes against its actual direction, right? So this is upward, rotate, go to X. So the correct direction is upward. Okay. So now we know this force, this resultant, rather, is upward. So now, how can I solve for R? You're going to solve for R using your given. So moment about A. Let's start with moment about A. So recall, our equation for moment is FB. Okay, so we have this. MA equals summation of FB. MA again is 120. Now we need to get FB. The only force here is this. That given as resultant. Oh no, it's just F. So this is just F. Okay. So once again, the only force here is this. Okay, and then perpendicular distance about A is this distance, right? Once again, to get that distance, it's a bit tedious. So instead of doing that, we're going to use Varadon's theorem, which is dividing your force into its x and y components. Now, one thing about components is you can place it anywhere along the line of action of your force. For example, here, this is my force. I can put my line of action or rather, I can put my components anywhere. Could be here, and here, 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 or even here. Okay. Now you're gonna put it in a position that makes your equation easier to solve. Okay. Now the answer to that, to where should I put my force or my component, is here at point C. So this is the component, point C. So let me separate that drawing. Okay. Redrawing everything. We have this. You have your force F. This is your F. This is your point C. This is your A. And then this is D. And then we have point B over here. Let's draw our distances. This is 3, this is 2. And then this total thing is 5. Okay. Just so you can see it clear. Okay. Once again, this is where I'll put my fx and fy. So, once again, fy, fx. Now, why did I put it here? Now, notice this fy actually passes through A. Now, another thing about moment is any force that passes through your moment center doesn't create moment about that point. So meaning this fy doesn't create moment about point A. Obviously, because there's no distance between them. So D is 0, therefore there's no moment. Now, the reason why I put that here is because of that. So you can just ignore fy completely in our equation. Okay, so write out our equation going back here. This is your f. Let's start with fx. First thing to know is the sign. So rotate fx about point A, since again we're taking moment about A. That's clockwise, therefore positive. So positive fx. Okay, and then multiplying it by perpendicular distance. Distance of this from point A is this length, which is equal to 2. This is 2. Times 2. And then once again for fy passes through A. So you can just ignore that or just write plus 0. From that, I can solve for fx. Please solve what's fx. Correct, it's 60. This is just 120 over 2. Correct, Rafaela and Colin. Ray and Pauline. Okay. It's 60. Pounds, right? Or just 60. Next, let's do the same thing and use FB, MB, moment FB. Okay. So I'm gonna copy this just to make things clearer. Now to solve for MB, instead of taking moment about point C, sorry, instead of putting our components at C, we'll put it at a different point. Okay. So MB equals 70. That is summation of forces multiplied by their distances. So this is F, moment about B. This is the perpendicular distance. Once again, that's too tedious to solve. So we're going to use component method or Baranon's theorem. Now, based on this, we're taking moment about B. Where should I put my components so that one of them cancels out? Anyone? Where should I put my moment? Okay. You're correct. Both of you are correct. Francisco, he would like to put it at D so that if you write your components this way, right, fx cancels out. However, the problem there is I don't know this perpendicular distance from B. All I know is this is 5. I don't know this. So that would be hard. So that option is not available to us. Instead, we're gonna use C. Okay. Since I already know fx, so if I use that equation, I can solve for fy. Knowing fx and fy using Pythagorean theorem, I can finally solve for it. Okay. So technically, you're both correct, Naomi and Mrs. Delgado and Mendoza. Okay. Once again, I can't choose D yet since I don't know this. So we're left with this option at C. So this is Fy, this is Fx. Let's create our equation. Let's start with Fx. Rotate Fx about B. So that's counterclockwise, right? So that's negative Fx. Get its perpendicular distance, extend its line of action. This is the perpendicular distance to B. And this is equal to this, which is equal to 3. So that's 3. Next, Fy. Rotate Fy about B. So drawing that, we get this. So that's clockwise. So positive Fy. Then perpendicular distance. Okay. This is the line of action. This is the perpendicular distance to B. And that is equal to 5. So times 5. Knowing that Fx is 60, I can solve for Fy. What's the answer? Correct, it's 50. So Fy is 50. Correct, Kurt and Naomi. De La Cruz. Kurt. 50. Let me check some. Okay. 3 points ka na pala, Naomi. So not Naomi. Let's give it to Zyra. Please. Okay. Right. Now we have Fx and Fy. Okay. You can solve for F. Square root of Fx squared plus Fy squared. We solve knowing that 50 is Fy and Fx is 60. Correct. It's 78.10. Correct, Rafaela and Kurt. Malana and De La Cruz. $78.10. Unit is pounds. Once again, we're not done. We should also solve for its angle, theta, which is just arctangent Fy over Fx. Please solve. What's the answer? Correct, Kenneth and Eman. And Zyra as well, and Kurt. So Kenneth, De La Cruz, Kenneth. Apat na yung De La Cruz. And then Kurt and Zyra, you already have 2 points. So let's give it to Eman. 2 points ka na ba? Yep. Once again, yung mga naka 2 points, refrain from answering for a while. Michelle, correct. Right. So again, this is 39.81. And then let's take our sign. So looking here, okay, both are positive. However, this is by comparing two answers. Okay? For this case, positive sign just means correct assumption. So here, correct assumption, FY, so that's upwards. So again, here, correct assumption, which is to the left. So the direction here is to the left, or upwards to the left, or up to the left. Okay? Once again, in this case, this is already assuming the direction of our forces. This is comparing two answers and solving for a variable. So therefore, the positive sign just means correct assumption. So for fx, we assumed fx to be to the left, positive, therefore correct. It is to the left. Same thing here. We assumed fy to be upward, therefore it's positive. So correct assumption, it is upward. So direction is up to the left. Okay? Or southwest. Now we have f. Finally, we have to solve for this, your ix. So how do we solve for that? So once again, we're going to use the concept of moment. So let me copy this once more. Put it here. Okay. So we need to solve for ix, meaning I need an equation that includes ix. And to do that, we're going to do what we mentioned earlier, which is put our component at point B. Okay. Y, this is point B. Okay, let's create our equation. I'm going to use this given moment about B. Okay. You can also use moment about A. You should get the same answer, but let's try using the moment about B. MB is equal to summation of forces B. Okay, same equation. MB again is 70. However, here we took our component at this point. In this scenario, we're taking our component at point B. So our equation will be different. Notice fx passes through B, therefore ignoring that. Next, fy. Rotate fy about B, that's clockwise, therefore positive fy. And then perpendicular distance. That perpendicular distance is this length, and that's equal to 5 minus ix. So 5 minus ix, or intercept on the x-axis. Now, luckily, we've already solved for fy, and that's 50. Therefore, I can solve for ix. Please solve. What's the answer? Correct, Alyssa and Francisco, so Legado and Tamayo. Okay, Tamayo. Tamayo. Alyssa. Amel. Okay, right, 3.6. unit feet. Since here, pound foot. So unit feet. Okay? That's our answer. You can try practicing this by taking moment about A. However, still taking your components here. So if you take MA equals summation of forces, you get 120 equals, let's start with Fy, rotate it about A, that's clockwise, and then perpendicular distance is your Ix. Okay, so you still have an equation relate using Ix. So once again, if you want to practice, do this, but instead of moment at B, you do moment at A, and then you should get this. All right, that's our number 1 for moment. Any questions for number 1? Once again, please answer in the chat. Any questions? How about how about the others? Please answer. Do you have any questions? Can we use moment at O? No, you can't because we don't know what is the moment about O. In the initial solution, you can't yet. Because again, you don't know moment about O, it's not given. However, since we know Fx and Fy, here for this third problem, you can use moment about O. Okay. And then you just have to solve for it. Oh wait. Yes. Moment about O and then taking your components here at point C, you'll be able to solve for moment about O. And then after knowing the answer to that, you can now move your component to point D so that you can solve for Ix. It's a longer solution, but you may do it as well. Okay? Any other questions in general? No. All right. So, no questions. The next question has a bit of a long solution since we're taking moment about A, B, C, and D of each course. So we'll have 8 answers for number 2. Okay? I don't want to rush. So I'll leave number 2 and the rest of the questions for the next meeting on Thursday. Okay? So that ends our topic for today. You can try solving for this on your own since you already know the concept of moment. And then just compare in class if you got the correct answer. Right? That ends that. Thursday, continuation of lecture. Saturday, sit work. Now, for the late enrollees, okay, if you didn't see our announcement, please check or read or watch our orientation. Let me show you that. Okay, homepage. Yeah, so blackboarding seat work on Saturday. I'll announce it on Thursday. So go to announcements, read that. Right. So we had a diagnostic exam last Saturday. Please answer it. You have until this Saturday to answer that. And then you need to send me an explanation letter with signature of your parents, ID of your parents, and reason with proof on why you weren't able to take the exam. So for late enrollee, just tell me you're a late enrollee explained by your guardian or parents. Okay. Aside from that, please watch our past recordings found here, and also check out the PDF files. Okay, so that you can catch up to whatever you've missed. Okay, and then as you can see, week 1 is your diagnostic exam, hard deadline this June 5 at 1:30. Okay, any other questions, concerns, clarifications? Right, Lana? Okay,
Ano po yung gagawin sa classwork?
your seat work, Saturday, you're just gonna answer a problem set.
Okay po.
I'll upload it on Saturday as well. You have the whole day to answer your seat work or classwork. There won't be any Zoom meeting on Saturday. There won't be any Zoom meetings every seat work or classwork day as well. Okay? And no more questions? All right. Since you don't have any more questions, see you on Thursday. Goodbye, class.
Bye, ma'am.
Po, ma'am.
Thank you po, ma'am.
Thank you po.